Welcome back. This is module 2 of capital investment. In our previous lecture, we have covered some of the basic concepts of capital budgeting, and in this lecture, we are covering net present value. Now, let's look at what is meant by net present value first. Net present value means present value of project's cash inflows minus cost. In general, the cost is normally the initial investment of the project. The cost of capital is used in net present value as the discount rate. Probably you know that the cost of capital is the expected rate of return that the firm could earn by investing in a different project with similar risks. So, net present value is the sum of present value of all expected incremental cash flows, and the discount rate which is used to find out the net present value of a project is the firm's cost of capital. Here is the formula of net present value. Here CF0 indicates initial investment, which is normally a negative cash flow. Then R indicates cost of capital, and CFN is the after tax cash flow at period N. So how do we evaluate projects based on net present value? If net present value of a project is more than 0, we will accept the projects, and if the net present value of a project is less than 0 or negative, we will reject the project. Here is a solved example of NPV. The weighted average cost of capital, or simply the cost of capital of both projects, is 10%. There are two projects here, project S and project L. Both projects have a cost of capital or initial investment of $1,000 million, and these are the after tax cash flows of these projects. Both projects will run for 4 years. Here project S will generate $500 million in year 1, then $400 million in year 2, $300 million in year 3, and finally $100 million in year 4. Based on these cash flows and weighted average cost of capital, NPV of project S is 78.82 million. So here is the calculation of project S NPV. The initial investment of this project is $1,000, so it's a negative cash flow. Then in year 1 it will generate $500 cash flows divided by 1 plus 0.10, which is 10% cost of capital to the power 1. Then $400 divided by 1.10 to the power 2, $300 million divided by 1.10 to the power 3, and finally $100 million, which is the fourth year cash flow of project S divided by 1.10 to the power 4. So based on this, NPV of project S is $78.82, and NPV of project L is $100.40 million. So both projects NPVs are positive. So based on the criteria of NPV, both projects are accepted. However, if projects are mutually exclusive, we should accept only project L, because in case of mutually exclusive, if we accept one project, we have to reject other one. In that case, we should accept project L, because NPV of project L is more than the NPV of project S. So it indicates that project L will generate more value for the firm. And if the projects are independent, we can accept both projects, because both projects have positive NPVs. So we know that if projects are independent and if they are acceptable, we can accept all projects. Now let's look at the reinvestment rate assumption of NPV. NPV method assumes that project's cash flows will be reinvested at R, which is the opportunity cost of capital or simply the cost of capital. That's all about this lecture. In our next two lectures, we'll cover NPV in Excel and internal rate of return.